Hi everyone, Linus Herbal is here with a continuation of a Terraform vCloud Director Provider demo. This demo builds on top of the previous one for the provider perspective, and instead focuses on how tenants can use Terraform. During the previous demo in this vCD instance, we have automatically created a complete organization for a tenant with networking to the outside world. Now, let's switch to the perspective of the organization administrator. As you can see, for now, the organization is quite empty. Here is a new Terraform configuration file. It connects as the organization administrator, and it will create a free tier networked vApp with a database in one network, a backend application hosting a REST API in another network, and a client-facing web server consisting of two load-balanced virtual machines. Here we define the edge gateway name and edge gateway IP address, and the first thing we do, we need a Linux OVA, for which we create a new catalog and upload a new catalog item. Then let's prepare three new organization networks. One for the database layer, one for the REST application, and one for the two web servers. Now let's define a vApp which will contain all our virtual machines. In this vApp, we first create a database server. This VM is connected to the database network. In this server, we start an imitation of MySQL database, listening on the default 3306 port. Now let's define the REST application server, which connects to the network for applications. In this server, we will listen on port 8888. Let's create some NAT rules for this server. One SNAT rule to allow traffic out for things like system upgrades. One DNAT rule to be able to access our created REST API endpoint on the port 8888. And one DNAT rule to access the machine via SSH. We will use this to connect and demonstrate the server's connectivity to the database server, which we defined before. And last but not least, we create a load-balanced web server. This server contains two machines. It's very easy to define that with Terraform. And they will run a simple web page which prints the server name and references data from the REST application server above. This section at the bottom defines the load balancer and how to share the traffic. In this case, it's a simple round-robin algorithm. The virtual server itself is listening on the default port 80. We also create firewall rules. One to allow access to the web server, two to allow access to the application server REST and SSH ports, and one for the application server to access the outside world. Of course, there is no connectivity to the database from the outside. Having this configuration, let's run a single Terraform apply command. It will create all these resources for us. Let's give it some time to do its job. It is now launching our virtual machines. Terraform takes care of all the dependencies, so the configuration is happening at the right order. For example, DNAT rules are configured only now when the app server was launched. All the virtual machines have been deployed, and now the edge gateway configuration is taking place. Oops. In the middle of applying this whole plan, I lost connection to my vCD instance. However, what is really reassuring about Terraform is that it always knows its last state. So, I just ran Terraform apply one more time. It compared its state file with what has been deployed in vCD. And it understood that there are only a few resources missing. And seamlessly created only the needed ones. So now we can look at our deployed infrastructure. Let's check the vApp. It has all 4 our virtual machines. And if we check the diagram, we can see the connectivity. So here is our database server connected to the database network. Then we have the application server on the application network and 2 web servers on the web network layer. Let's check the edge gateway. Here we can see all the firewall rules that we defined, all the NAT rules, and one created for the load balancer automatically, and the load balancer pool, and of course the virtual server. So let's test it. Let's test whether it works. I will navigate to our public IP address. As you can see in this web page, I have a response from the web server. This is the server name. And also I have a response from the application server. If I force refresh this web page with cache reset, the server is changing because it is being load balanced, while the response from REST application is still the same. Let's check connectivity to the REST application now. I'm connecting to the 2227 port that we have DNATed. Let's check whether the SNAT works. It does. And finally, let's check whether we have connectivity to the database, which resides on a different subnet. And here we are. To conclude, by using the Terraform vCloud Director provider, we have automatically created a free tiered application and network stack with all the connectivity to make it actually work. By accident, we have also seen how Terraform is resilient in the face of environment instability. As you can see, it's a pretty powerful tool. Please give it a try, and thank you for your attention.